my name is Bella Barber, and today I'll be telling you about how to make alum from aluminum. Essentially, we took pieces of aluminum foil, which went through a series of chemical processes and synthesized alum. So to start, we took pieces of aluminum foil, broke them down, weighed them out, and dissolved them in a solution of potassium oxide. So basically, by adding the potassium oxide, we broke down the solid structure of the aluminum foil into solution, and eventually we isolated the aluminum hydroxide. So after this first initial step, we had to filter out any impurities that came out that were found in the aluminum foil, because we want to just isolate the aluminum hydroxide. So after filtration and the separation of the impurities, we added 9 molar sulfuric acid. So essentially, this acid neutralizes the basic aluminum hydroxide precipitate that has come out of the solution, and we add even more to dissolve the solid hydroxide. So basically, we want to take the aluminum hydroxide, break it into its most basic components, and take out only the alum, which is potassium aluminum sulfate dodecahydrate. So next, we precipitated crystalline alum from the solution. So in order to do this, we had to place our solution into an ice bath. And by lowering the temperature, the solution was less soluble, and so our solid precipitated out, which was the alum that we wanted to isolate. And then after we isolated the alum, we wanted to dry it. So we dried it using vacuum filtration, got rid of all the liquid, and it was left in a white powdery form. So and now we have our alum, and we want to make crystals. So in order to make the crystal growth, you essentially need to evaporate saturated solution of alum. As of now, the crystals that have formed are very minimal in our vial. As you can see, there aren't any noticeable crystals that have come out. There's a small white layer on the bottom where you can see crystallization starting to occur. But in terms of size, they're very small, shape noticeable. We can't see the shape of the crystal formation with the human eye, and there's very few in number. But a reason for this is that not enough of the solution has evaporated yet. With the experiment occurring just less than 24 hours ago, there has not been enough time for this evaporation to take place, which is key to crystal formation in our experiment. So therefore, it'll take time and patience for our crystals to grow. So now that we've determined how to make crystals out of a material like alum, we want to be able to apply this to other salts. So in order to grow crystals of a salt like sodium chloride, it's essentially the same process. We want to evaporate a saturated solution of whatever the salt is. So if we wanted to make crystals of a salt like sodium chloride, we would essentially have to break down the sodium chloride into a solution. The solution would be of water and salt. So in order to achieve this, we could boil water with salt in it, and determine that the solution is saturated, which would mean that adding a little more salt than the saturation limit. As we have seen, evaporation is just one of the many ways that we can synthesize crystals. According to MIT's Department of Chemistry, sources will be cited at the end, we can use many other methods to create crystals. One method is called slow cooking and involves taking a saturated solution, transferring it to an open container, and covering it. We would then place this into a heat bath and slowly cool the solution. By slowly cooling the solution and manipulating temperature, we will make the solution less soluble, and therefore solid precipitate will come out of the solution.